Okay, I hear our conversation drifting a bit. So what did we come up with?
True.
What makes something an independent variable, Hunter? Okay, so this value depends on what is put in for the independent variable. So it depends on the value of the independent variable. So what does that mean the independent variable does? Where does that come from? Any thoughts on that? Okay, somebody tell me something you know about an independent variable. I will guide us in the direction I want to go.
Is that what you plug in for a variable?
Yep, it's the number that you're plugging in. What's another word for that? The input, okay? This is the value that we can control. Okay? Or the value that kind of controls itself, I guess I should say. I would have said, up until like 3 days ago, for example, that time is almost always an independent variable. Okay? Because when you're doing like an experiment, for example, you're not testing the effect on time. Like time doesn't change, right? You look at like what happens in 1 hour, what happens in 3 hours, what happens in 5 hours, and then you're studying the effect of time on something else. So time is almost always independent. However, I will tell you that I was looking at your worksheet. I think it's even the worksheet that you're doing today. And one of the problems talks about the speed of a train and how much time it takes to reach its destination. Well, in that case, it's not the time that you're controlling, it's the speed, right? And the faster you go, the quicker you get there. So in that case, the speed would be the independent variable, and then the time is affected by how fast you're going. So that sort of rocked my world in terms of independent and dependent variable. Hunter?
Independent is y-axis.
Independent is actually x. Yep. This is typically your x value, which means the dependent variable is what? My y value. And then similar to here, so the independent variable is what we are plugging in. The dependent variable is what the outcome is. So this is always like the outcome, otherwise known as the output. Okay. So we're going to be looking at sort of real life data or real life situations, as real life as it ever gets in a math book. But we need to be able to differentiate between what is the factor that we are controlling or we are looking at, and then which one are we studying. We're looking at the effects of this on this, okay? And so whatever you're studying the effect on, that becomes your dependent variable. Now, I want to give you this rule of thumb, not because I want to take your brain away from you, but because I want to make this easier for you. If a table is presented to you, and if the table has been drawn up correctly, meaning it's been drawn up by somebody who knows something about math or something about variables or, scientific experiments or anything, if someone has drawn up the table correctly, the independent variable is the first list, okay, or the first set of data, and the dependent is always your second set. Now, the people who wrote your textbook, do you imagine that they know at least a little something about math?
Maybe.
I sure hope so. Okay? Which means that the data that you're given in like worksheets or in your examples or anything like that, you can go ahead and assume that whatever the first list of numbers is, that's your independent variable, and then the second list is your dependent variable. But if you were out collecting this data yourself, if you were doing like a lab experiment and you were looking at, how many bacteria you have based on how many hours it's been multiplying, something like that, you would have to be able to determine which one's independent and which one's dependent. Okay? Does that make sense? I hope. Yeah. Okay. The other thing I want to point out, when we write our variation equations, or when we write that sentence, you know how there's always like that key sentence to one of these problems? it's always y varies somehow, okay, directly, inversely, blah, 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 as x. So just remember that this value over here is your dependent. This value over here is your independent. Okay, so you're messing with the x. And remember, this is the one that always has the k value attached to it. So I had somebody in second hour say, the independent variable is the one that's by itself. And I totally get where you would think that, okay, because that's what independent typically means. But if you look at like any kind of equation, y equals 2x plus 5, this is what we're plugging numbers into, right? So this is actually your independent variable. And then you are studying what happens to the y value when you plug different numbers in for x. So the independent variable is the one that's in the expression or in the equation, and then the dependent is always the outcome. It's always the answer to your equation. Okay? Good? Okay, so these are the kinds of problems you're going to be faced with today. And I'm going to give you a second so you can jot down that list of numbers.
Can you slide back up a little bit?
Sure. Copy some of that stuff down. Is that enough? Okay. If you need to still copy some of that stuff down about independent versus dependent, and then you will want this table on your paper, and I'll slide it up in a second for those of you in the back who can't see it. But it doesn't have to be beautiful. You just want that list of numbers down in front of you.
Are we done writing on that?
In the boxes, yeah. Yep, go ahead and do example 1. And I think my goal is to get through example 1 before we leave for lunch, and then we'll do example 2 when we come back.
Ooh, it's gonna take that long.
The calculator part might. Which, keep in mind, I caution you about this anytime we use something with the calculator. The first time we do anything on the calculator, it seems like it takes forever. Okay, because I have to show each step, I have to wait for everybody to be with me, you have to find the right buttons, things like that. And so I feel like every time I demonstrate something on the calculator, I'm saying like, oh, this is going to make your life easier, and you're thinking, oh my gosh, it took me 20 minutes to do that problem. Okay, it won't really when you're doing it by yourself. Okay, it'll go a lot faster than you think it will. But go ahead and jot those numbers down so you know what you're working with. And what this is comparing is like a scuba diver. As the deeper they go into the water, and I noticed last hour I didn't put a measurement on here. This is depth measured in feet. So as you dive deeper and deeper into the water, the pressure that's being put on you gets bigger and bigger. Okay, so this is a measurement of how much pressure is exerted on a scuba diver based on the depth. What's that?
What about the label of pressure?
It says up here that pressure is in pounds per square inch. So this is PSI. But I don't think I put the depths measurement in here anyway. Okay. Really, that doesn't matter to you mathematically, but I just want you to have a sense that that this is accurate information here. Okay, so you can see that the depth is our independent variable, so that's like our x values, right? Because we're not controlling the pressure, we're controlling how deep the scuba diver is going, and then we're measuring the pressure at different depths. Okay? So it says write a variation equation. And you guys would be totally fine with this if I said to you, the depth varies blah, blah, blah with the pressure. Or sorry, that would be the other way around. The pressure varies blah, blah, blah with the depth. What's missing is that sentence, right? But I want you to take a look at this data. What do you notice about it in terms of what kind of variation it might be? Any observations?
Direct.
Why do you say direct?
Because both numbers are increasing.
Okay, because they're getting bigger together, right? So we know it's some kind of direct. What we don't know is if it's linear or if it's quadratic, meaning is it just regular x or is it x squared? Eventually we could get fancy and go with x cubed and x to the fourth, but right now we're not doing any of that. So here's what we need. We need to be able to see this on a graph. We need to be able to see these data points because then we can look at it and say, oh, the shape of that graph is linear, or the shape of that graph is a parabola. And then we can determine what kind of variation we're dealing with. The calculator helps you see that data without having to draw the graph by hand. Now, there's nothing wrong with drawing the graph by hand. There's some in the homework that you have to draw by hand. But the calculator, if you just need a quick picture of it, I'd use the calculator. So here's what we're going to do. And probably, especially if you're using my calculators, you're going to have some junk in your calculator from last hour, so we have to get rid of that first. Whoops. That's not what I wanted to say. So in your calculator, the first thing I'd like you to do is go to the y equals, and if you have anything in there, clear it. Okay? And if you have this plot 1 turned on, meaning does it have that dark rectangle around it, you can move your cursor up to the top there and just hit enter to turn it off. Okay, so I want you to start with it turned off. Spoiler alert, I'm going to have you turn it back on a little bit. But I want you to see the whole process. And not everybody's was turned on, so if we all start with it turned off, we'll be okay. Okay, then I want you to find the stat button, which is next to your arrow keys there. So let's hit stat. And the very first option is edit. So you're going to choose edit. Now, if you have not done anything with this in your calculator before, these lists are probably blank for you. I'd like them to be blank. If you are using one of my calculators, they probably still have numbers in from last hour. Here's how you can clear out the list. You could go through and delete each number individually. That's annoying. Or, and pay attention to this, watch me first, okay? Because otherwise you mess things up. If you go up to where it says L1, so I moved my cursor up to L1, hit clear, and then enter, okay? And that empties all the numbers out of the list. And then I'm going to go over to L2 and hit clear, and then enter. The one thing you don't want to do, though, you don't want to go up there and hit delete, okay? Because that makes it so the whole column disappears, all right? So that's why it's important that you use clear and not delete there.
Where's delete?
Delete is up here next to the arrow key. But, yeah, but don't do that one. Stick with clear, right? Stick with clear. Okay? Okay, so now in list 1, we're going to put our independent variables. Okay, so we're going to put our depths in there. Now I'll put this where I can see it. So 0, 10. Hit enter in between each term. 40, 55, 75. And then what do you think we're going to do? Go to list 2 and put in our pressures. .8, 17.2, 23.7. Okay. Good. Have I lost anybody yet?
No.
Okay. So I've got all my numbers in there. Now, the next thing I want to do is I need to tell my calculator to make a graph based on these numbers. I need to tell my calculator, take this information and put it on a graph. And the way you do that is you go up to your stat plot, which is up above y equals, so you'll have to hit second and the y equals button. So you get to a screen that looks like that. And then let's choose this very first plot. And all of this stuff down here should be able to just be left the same. Let me give you a quick rundown of what all this stuff means in case you do ever need to switch it. But this is just saying you want to make a graph that's individual dots. You can make a graph where they're connected. You can make like histograms. You can do all kinds of stuff. But you just want dots right now. Okay? This is telling your calculator, here's where those numbers are located. Okay, I want the numbers that are located in list 1 and list 2. And then this is just what kind of dots you want to show up on your graph. If you want to change the kind of dots you have, feel free. Okay, I don't care. So the only thing we need to do is we need to turn it on. So right here where my cursor is blinking, I'm going to hit enter to turn it on. And then I'm going to make a graph of it, but I want to tell my calculator, actually let me do, just watch me first, or yeah, just watch. Don't touch anything on your calculator. This would be if I did the graph on just a regular home screen, okay? If you're using one of my calculators, it's probably already changed from the home screen, so yours isn't going to do this. But what's the problem here?
It's not zoomed out.
Yeah, I need to see more of the graph. And what part of the graph do I not care about?
Negatives.
Everything negative. And here's the thing that's the difference between math land and real world. In math, negatives make sense all day long. There's all kinds of math we do with negative numbers. But in real life situations, negative numbers rarely make sense, okay, in terms of data collection. Maybe if you're working with temperature or something else where like a negative value makes sense. But for the most part, we don't care about all of this, okay? So I can tell my calculator to zoom in specifically on the dots that are graphed. And here's how you do that. This is where, I wouldn't even do window. Window requires too much thinking, okay? Not that it's bad to be thinking. But your calculator does this part for you. If you hit zoom, and then scroll down, I believe it's number 9, at least on mine it's number 9. Zoom stat. And what that's telling your calculator is make a graph that fits those data points that we just graphed. Okay? So if you hit number 9 and hit enter,
Oh my.
beautiful, right?
Oh my god.
Okay? Again, that process is a lot quicker when you're just running through it by yourself. Okay? When you're just plugging in
every
numbers.
single time.
If you leave the stat plot turned on, you don't have to do that piece of it every time. What you would have to do is do the lists again, and then you'd probably have to zoom it in again, zoom stat, just to fit your new set of numbers. Does that make sense? So every time, all you have to do is plug the numbers into the 2 lists, and then hit zoom stat to get your graph to reconfigure where it should be looking. Does that make sense? Okay. All right, so the purpose of doing that was to see what kind of graph this is. What kind of graph is this?
Linear.
It's linear, which means it's what kind of variation?
Direct.
Just plain old direct, right? Okay, so now I'm going to go back and do some real math here. I know it's direct variation now, so I'm going to say it's y equals k times x. And in order to write a variation equation, what do we normally do at this point?
Plug in.
Because we need to find?
K.
We need to find k. Now normally, I would just hand you I would give you 1 pair of values. You have a lot of pairs of values. Does it matter which one you choose? It shouldn't. The only one I would stay away from, 0, 0. Okay? That's not going to get you any good information there. So let's just pick, I don't know, the 10 and the 4.3, because that's easy for me to do mental math with. Remember, this is my y and this is my x, so 4.3.
They have to be from the same column though, right?
Yeah, you do have to do a pair that goes together. So this would be k times 10. Divide by 10, and I get 0.43 for my k value. Okay, oops, sorry, that's kind of low. Oh, that's not what I meant to do either. That's right. So now I have my k value. Now can I write a variation equation? It would be y equals 0.43 times x. And so now I could say this equation models the situation. This is a model for this scenario. And I could use that equation to calculate the pressure at any depth. Okay? And we're going to talk more about this in the next chapter. We do a little bit more statistical stuff in chapter 3. But, for example, I could figure out what would the pressure be at 30 feet below the surface. I could figure out what's the pressure at 100 feet below the surface. Just out of curiosity, because we're talking about it right now, which one of those do you think would be more accurate? The predicting it for 30 or predicting it for 100 way out here?
30.
Why?
It's just a low number.
Okay.
So it won't be as much of a range to
That's a
divide.
good point. Any other thoughts about why 30 would be more accurate? Okay, we're going to talk more about this in the next chapter, but 30 is inside my set of data that I use to make up my equation, right? So 30 is within that set of data, so I know that this equation works for these numbers. Is it possible that something crazy happens after 75 that I don't know about? Like maybe after 75 it takes a curve or something like that. And so I don't know as much about what happens beyond my data set as I do what happens within my data set. Okay? But like I said, we're going to talk about that more later. So now, theoretically, I should be able to plug in any one of my x values, like 55, to my equation. So 0.43 times 55. And it should come out awfully darn close to my y value. Now, again, the only place that things work out perfectly are in math textbooks, okay? In a real life situation, is it possible that we would have measured like 24 and then our equation gave us 23.7? Yes. So being a little bit off is not a big deal, okay? Because this is just a general model. It's not like a specific, this is exactly what happens every time. Good? Does that make sense? Okay. Why don't we do this? I know your bell's about to ring. I'm going to put up the second table of data so you can maybe at least get the table written down before you leave for lunch. And then when you come back from lunch, we'll do this one together. So if you want to try to get that table of data down before you go, that'd be great. Okay? And I'll leave this up so that as soon as you come back in, if you need to finish copying it down, you can. Oh, that's probably why. Okay. So yours, remember I said the thing about not hitting delete? I was going to say, not that you did it, but that's essentially what happens is you lose your list one. But I can put list one back.
You said a really big thing.
Okay, I had this happen before, and I literally use a memory.